charger. Consumer being built for the charging the vehicles is also going to be next area of interest, how the billing mechanism has to happen for the charging. And how the utility will look like. I mean, we have talked more about the smart grid, but the whole utility will be looking totally different from what it is today. And maybe it will go for the further transformation with respect to various areas. And there will be a combination, I think this all along, the hardware management, reporting software at the top, and intelligent communication infrastructure, everything. And this is what I thought I'll just share something. The secure transmission and distribution system, as the technology advances, become increasingly reliant on a secure electricity supplies. I think technology is also helping us to be more and more secure electric supply. As the demand for electricity rising every year on year, the concern on the environment is also increased. So the renewable integration is going to be a major part of that, because renewable will definitely play a major role in the coming years. Though we have about 65% of the generation is from the fossil power, thermal power, but in the years to come, probably it will increase. If you have seen, you have heard about the other countries, they are looking at 25 to 30%. Maybe our country is looking at least 10% in the coming years. And that 10% of renewable integration with the variable generation, it is going to be a big challenge for us in terms of integrating the grid. And you just heard from Shiva that Tamil Nadu is not able to use the grid because although the power was available on the grid, I mean in terms of generation, the wind generation. So that's the kind of challenges which are going to happen. Whether that requires the capacity enhancement or the capacity in terms of the grid, the transmission structure, or is it the information technology which can help them? I think this is the question to be asked to us, the technologists. Many companies offer a sustainable solution to the challenges of today and tomorrow. So what is also to be looked at, I think, in terms of an excess of power, but we still have about for the 1/3 of the population is still without power. I mean, there are solutions possible to give them. The microgrid could be one of the best solutions with the added the storage devices. Probably that can help the country as such. I think that will be probably the solution for the future for all the developing countries in the world. Because if we are not exploit the potential which is available in the country in terms of both solar as well as wind. So this how I think this probably the slides you must be seeing in many places, but I don't want to talk on this. I just still come to a renewable focus and integration. If you see the whole, the focus is shifting towards the renewable. Why? Because the high concentrated fuel, which used to be for the last so many decades, is not getting, it's not enough the high concentrated fuel is available, and it's not going to be available in the future. And that's going to bring us a lot of focus and a lot of thrust on the increasing, that is the renewable, the low concentration fuel, mainly the renewables and the solar. And that is also becoming much more complicated as far as the handling is concerned. Because when you look at the coal mining, it was probably much easier to do that earlier. But now today, when you're coming to the renewable or the wind, it's going to be much more the complexity in terms of. So we lived for many decades, and in a situation of high concentrated fuel, now moving toward the increasing difficult situation that is more failures, and that's what leading to the increased demand for the renewable energy and the capacity enhancement. This is what the slide I borrowed from someone's place. If you see that how the whole status of the various fuel is going to exist, and in probably the renewable is the only area which can remain for a much more number of years. Probably I and you may not exist in this, but then still, this is going to be continued for the many. So peak oil, peak natural gas, etc. talks are on. We are reaching the limits, and every doubling capacity of renewable yield is 20%. Because the cost goes down when you have a more renewable energy, the penetration to the grid. Electricity is generated with no taxing of the planet. This is how the future is going to be in terms of the solar. And the photovoltaic is going to actually capture about 64% by in 2100. That's the estimate which the predictions are on. This is from the Global Energy Mix exemplary path from 2050 to 2100. This is from the German Advisory Council of the Global Change, which predicts that at least 64%. And many countries have already come with the policy in terms of introducing the renewable energy to the major part of the. So what that means, that with over 40% of the worldwide electricity usage, buildings can be considered as the largest consumer of the energy. And therefore, the architects, consultants are also working towards, I think, I don't know how many of you are aware of that, they're already building code which is coming up with integrating the BIPV as the part of this. And the photovoltaic technology is the promising solution, transforming the solar radiation into the electricity generated. This is one of the, I thought this, I'll share this with you. This is one of the slide which I picked up from the Danish government. The opposition party leader says that she's going to have a more renewable energy. And also she says that she's going to have more renewable energy because India and China is using more and more vehicles. Because that means we are using more and more the gas and the petrol. We are part of the arena, that is the Renewable Energy Association, the 91 states, the European, and India is a part of this member agency. I think India has the right focus, India has the strategy, India has the vision in terms of renewable energy, but there's a lot to be done in terms of the technology. And we have a huge potential in terms of wind energy. We have a huge potential in terms of solar energy. But we are not really, as a technologist, I think probably we are not. Maybe there are reasons for that. Maybe the cost reasons are there, affordability reasons are there. But it's changing. It is moving towards in the right direction, leading to a tremendous opportunity in the renewable energy. I'm not canvassing for the renewable energy, but I'm just saying that this is going to be the future of the country or the future of the world. The more and more renewable energy is going to be adding to the grid. And that poses a lot of problem. I think this slide was, again, the border slide. And more, the ICT is playing a role in terms of collecting the information and analytics. And there are a lot of challenges with respect to the renewable. One of the challenges is basically keeping the grid discipline in terms of voltage and the frequency. And the second one is how to optimize the energy generation or optimize the energy utilization. Understanding and quantifying the integration requirement, cost of higher levels of variable power generation resources, study integration impacts, and energy difference scenario, and the transparent and user-friendly model. So integration model has to be, renewable energy integration group is already there as a part of the worldwide group of ISO, and probably we can learn from that. The guiding principles are already created there. The visibility technical working group is there, and the dispatch technical working group on that, defining various technical limitations of the wind and solar dispatches. The model is simple, but we need to put this in practice. You have inputs on one side, you have outputs on the other side. Inputs is the installed variable renewable energy generation, the detailed profile of variable load and generation. Probably still on the solar side, we have still challenges with respect to the profile of the generation available in the country and in the world. The forecast errors for the load and generation, that is as an input, cost of conventional resources, and the model, and operating flexibility requirements, as well as requires the resource to generate this and integrate this, and the fixed and variable integration part. I'll just skip this. This is more detailed details of the models. What are the things to be addressed as a part of the model? And this is how the whole the 5 minutes and the 5 slot, the 5-minute variability and the 5-minute forecast error, intra-hour variability and hour ahead variability and day ahead forecast. So these are probably as possible in today's wind scenario, but in the solar scenario, we also have a similar model. And this is where the technology, the information technology will play a role in capturing the information on a real-time basis and then adding to the analytics. The load following and the day-ahead commitments, and this will help us to optimize the energy and the penetration into the renewable, into the grid. This is just an example how it should be. Just for example, the reliability requirements and also operating flexibility requirements. These are more important when you have a renewable energy which is more variable. So you have to have a band. That is, a band is additional capacity required for integration. I think this is what the model has to work on. And the fixed costs, variable costs, emission costs, probably that need to be also considered into the when you are providing the model. And it's a flexible tool. The range of results, refining the results on the basis of the practical experience will lead to a better results in the system. And the continuous improvement with the learning from the results will lead to a better working model over the period of time. So there's nothing like the model and it will be continuously improved as and when when you practice that as a part of it. So it's a continuous improvement. So if we can apply for a smaller applications and then lead to the bigger application, it will be probably the best approach would be at a microgrid level, so that you can replicate that or aggregate that into the much larger grid. That's what I thought I'll share with you.